Hi everyone, so in today's video we're going to solve an initial value problem where we have a separable ODE and an initial condition. And whenever we see a first order ODE, I strongly recommend that you ask yourself, is it linear or nonlinear? That's the first question we should ask ourselves. And if we look at this ODE and we multiply by 1 over dx, just so we can get the form of the differential here, we have x plus y e to the opposite of x dy dx is equal to 0. So when we write the differential in proper form dy over dx, we can see that this ODE is nonlinear. Because we have y times its derivative. So because of that, it is nonlinear. However, it is separable. So we could use separation of variables to solve this ODE. And the usual way we use separation of variables is to just try algebra and separate literally the variables. So x plus y e to the opposite of x dy dx. I shouldn't have erased that, but anyway, here we have it. Let's subtract x in both sides. We have y is y times e to the opposite of x dy dx is equal to the opposite of x. And here we can divide by e to the x in both sides and multiply by dx. So we have y dy is equal to the opposite of x e to the x dx. So here we successfully separated our variables. What's the next step? Well, next step, we simply integrate both sides. If we integrate both sides, this integral on the left is pretty easy. It's just 1/2 y squared. And the integral on the right, we have to use integration by parts. So even though it might be very familiar to you, I'm gonna do a side work here to evaluate this integral. So we have the integral of x times e to the x dx, and we'll leave out the constant, we'll just multiply it by it later. So we have this integral right here, and how we solve it is using integration by parts. So by using integration by parts, we can define the u to be x and the dv to be e to the x dx. When we take the derivative of u, we have du is equal to dx, and we have that v integrating both sides. We have v is equal to e to the x. And our general formula for integration by parts is the integral of u times dv is equal to u times v minus the integral of v times du. So translating to what we were given, we have that the integral of x times e to the x dx is equal to u, which is x times v, minus the integral of v, which is e to the x, du, which is dx. And we know that the integral of e to dx is just e to the x. So, I'm speaking too fast, sorry for that. This integral of x e to the x dx is simply equal to x e to the x minus e to the x plus a constant. So, let's get this result right here and substitute it in our final parts of this problem. So we have the opposite of x e to the x minus e to the x plus c. Alright, so when we have this right here, this would be like the general solution of the ODE. However, we were given an initial condition. When x is equal to 0, y is equal to 1. That is our initial condition. So by imposing our initial condition, x is equal to 0, y is equal to 1, this term vanishes. This term becomes 1 because when you multiply the two negatives here, it becomes 1. And when y is 1 here, it's just going to be 1/2. So C is just going to be equal to negative 1/2. There we have it. C equals negative 1/2. Now, what do? I'm going to erase the side work here to write our final steps of our solutions. So, the solution to this IVP is 1/2 y squared equals negative x e to the x plus e to the x plus 1/2 when we multiply this by this negative right here. However, this is not the final step. In this case in particular, it's better to write it explicitly because we have an initial condition here that's going to tell us something about the explicit solution. So let's write this solution explicitly. We're going to multiply it by 2 and we're going to take the square root. So y is going to be equal to the square root of negative 2x e to the x plus 2 e to the x plus 1. So we would usually write plus or minus the square root of that, but since we were given a positive initial condition, then we're just going to get the positive solution. So our answer is in fact the positive square root of negative 2x e to the x plus 2 e to the x plus 1. So this is the solution to our IVP. Thank you very much for watching this video. If you have any questions, please leave it in the comment section below, and I hope to see you next time.